Okay, so today we're going to look at 2.6, applying the trigonometric ratios. I can never say that right. Solving for all sides and angles of a right angled triangle. Now, if we're going to look at, so if we look at the first question here, it says solve this triangle. It's kind of vague with what it's asking. It's kind of a bit, doesn't really tell you lots of things. So what it means is solve for all of the sides and all of the angles that aren't already on the right angle triangle. So what we're going to be doing is we're going to be having to decide between sine, cosine, and tangent. So this is just a review of what we've done already. So we're going to decide and label the angle that's most important at the moment. This may have to be reassigned in a diagram with more than one triangle, or if you're finding more than one piece of information. You want to label all three sides of the triangle with the words opposite, hypotenuse, and adjacent. You can use O, H, and A for short. And what sides you have or need of the triangle is going to determine the trig ratio that you choose. So if you have O and H, you're going to use sine theta. If you have A and H, you're going to use cos theta. If you have O and A, you're going to use tan theta. And this is important. I have to mention this because we're going to get into more than one triangle questions. To minimize any error that happens when you're rounding off, you want to carry your digits in your calculator throughout a question. So for instance, if we find a middle line and it ends off and it's got some decimals that kind of dangle, you want to carry those numbers in your calculator the whole way. Okay? Often your calculator has a answer where it can recall the previous answer of your calculator so that you can it gives you the whole number, it doesn't cut it off. I don't want you to be retyping the number that you found into your calculator to do the calculations. Okay? So this is our first example. It says solve. And that's all it says. It says solve this triangle. Give the measures to the nearest 10. Okay, so what do we have? We have two sides, and then we have to figure out the third side and this angle and this angle. So which angle do you want to figure out first? You want to figure out angle N? Okay, so let's label that as our important angle. And then which trig ratio are we going to use in order to figure out N? So we'll call that, we'll mark it off like that, and we'll call this angle N. We'll say that's the first one we're trying to figure out. So if I label things according to N, what is this side going to be? This is going to be opposite, and this is going to be adjacent. Okay, and so which trig ratio are we going to use? Tan theta. So tan, you know what, instead of using theta, why don't I use N? Because it's directly related to angle N that we're finding. So let's say tan N is equal to opposite over adjacent, which is 7 over 11. Okay, now in order to figure out the angle, I need to write angle N is equal to, now folks, make sure you have the proper notation here, okay? What is the proper notation? Just you want to make sure you have the angle, you want to have the equal sign, the tan inverse. So how would I write this out properly so that anyone reading this in the math world can understand? Tan inverse, and then 7 over 11. So if we grab this on our calculator, want to make sure, what mode do we want to be in? What about this? Remember this here? This should be in degree mode. Yeah. So make sure your calculator is in degree mode. Second, tan, because I'm finding an angle, 7 over 11, and that's 32.47. All right. So angle N is equal to 32.471 dot, dot, dot. Okay, now, don't round this number off. Let's figure out what the other angle is. So can I figure out angle K right now? So what am I going to use to figure out angle K? So if this is 32 degrees, this is 32.5 degrees, what is this angle going to be right here? How do I figure that out? What property do I use? 180 minus 90. Angle K equals 180 minus 90 minus 32.47119 dot, dot, dot. Now what I mean, in your calculator, you could go 180 minus 90 minus, and then answer. So that'll recall the previous number, 57.528. And now I can round. So angle K equals 57.52880 degrees. Okay, so let's just nicely on the side here write out angle N is equal to 32 point, and rounding to one decimal places, 5, and then make sure you have a degree. Angle K is 57.5 degrees. All right, so those are my two angles. What do I still need to figure out? I need to figure out, still need side KN. All right, so what should I use to figure that out? What would you like to use? How many different options do we have? We have lots of different options, right? We could use Pythagoras. We could also use, what else could we use? Now that I have this angle, I could use any of the trig functions that have an h in them to figure it out. What's the simplest thing? Let's use Pythagoras, okay? Get a nice little review of Pythagoras as we do this. So let's figure out, so what do you want to do? We'll call this Kn squared equals Km squared plus Mn squared, right? That's just like c squared equals a squared plus b squared. I just wrote it using the line segment notation. So Km is 7. This is 11. And then in order to figure out Kn, I want to square root those guys. Square them first and then square root them. Add them together. Make sure you write the square root in each time. And then, so this is, you can see what I've typed in. So Kn, line segment Kn, is equal to 13.0, what are my units? Centimeters. All right. Okay, now for the next one, we have this triangle. So it says solve this triangle and then give the measures to the nearest tenth where necessary. You're given one angle and one side here. So how is your approach going to be different? Is it going to be different than the previous one? You're forced, what do you have to do? Are you able to figure out, what's the easiest thing that you could do right now, actually? So this is going to be your angle that we care about. This is going to be our opposite side right here. I could potentially figure out this angle. How could I figure out this angle? Yeah, by the 180 property, right? So 180 minus 90 minus 39 gives us that third angle. And which side do we want to find first? So there's your choice. So you could choose to find GH first, or you could find HJ first. It's your decision. Okay, so I'm going to hit pause and I'm going to let you guys figure this one out, and then we'll come back and finish it together, okay? Okay. All right, so I think I failed to mention the final answer of number 1. Just rewriting all the numbers kind of nicely over here so that we can see what our final answer is. Okay, now looking at number 2, it says solve this triangle again. When it says solve this triangle, what it's asking for, it's asking for solve all missing sides and angles. So eventually I'm going to have to figure out angle J. I'm going to have to figure out side G, H. I'm going to have to figure out side H, J. Those are the things that I need to figure out. So angle J is right here. That's right there. And then this is GH right here. And this is HJ. Okay, so the easiest thing to do first is to figure out angle J. Now we know a property of triangles is that the sum of the interior angles of all triangles add up to 180. So if we take 180 and we minus, and we know this little square represents 90, and we minus the 39 because that's the angle that we have right here for H, we get that J, angle J, is equal to 51 degrees. All right. Now, let's solve for what do you want to solve for? HJ? Let's solve for this guy first. Okay? Let's solve for HJ next. So if I deem this my important angle, and then this is going to be the opposite side, and this is going to be the adjacent side, and this is hypotenuse, that I'm solving for my hypotenuse side. So I'm going to use sine. So sine of angle H is equal to opposite over hypotenuse, which is 9 over, and this is my unknown, okay, which is HJ. So why don't I, instead of calling that a hypotenuse, why don't I label that HJ? Alright, now here in H I can put a number there, so let's go sine 39 degrees is equal to 9 over HJ. How do I solve for HJ? Multiply HJ on both sides, divide both sides by sine 39, and I end up getting this. HJ is equal to 9 over sine of 39 degrees. So what is HJ in this case? 9 divided by sine 39, that's 14.3. So HJ is 14.3, what are my units? Centimeters. Alright, now next let's solve for the other side. So I've got two options. I could either use Pythagoras, which is going to be a little messier because I'm going to have to use this number that I found, or I could use another trig ratio that involves opposite and adjacent. So why don't we use the other trig ratio? So let's figure out this side. I can use this side, and I'm going to have to use tangent. So solve for HG, and I'm going to use tan H equals 2, opposite, which is 9, over HG. Again, I've got my unknown on the bottom here, so instead of tan H, what can I write in here for the H? 39 degrees, put in the actual number. Okay, and so HG is equal to 9 over 10 of 39 degrees. So what do we get for HG? Okay, does that look right? Yeah, okay, great. So HG is equal to 11.1. How many decimal places am I carrying? Just one? Okay, so now let's check to see if I've figured everything out. So I've got angle J is equal to 51 degrees. I've got HJ, that's equal to 14.3 centimeters. And lastly, I just found HG, which is 11.1 centimeters. So, is that enough? Did I figure everything out? Yeah? Sweet. Okay. All right, and now there's this last example here that has to do with a window. It's the shape of a regular decagon. The distance from one vertex to the opposite vertex, so from here to here, measured through the center of the window, is approximately 4 feet. Determine the length of the wood molding material that forms the frame of the window to the nearest foot. So what's the approach here? You kind of have to break it up into triangles and then figure out what this molding is. So this is what we're trying to figure out, that total distance there. All right. So we're given this. So how can we use these triangles in order to figure out these lengths here? And how many are there? There are 10 of these. Okay. So let's take a commercial break and try this question on our own. Okay. And then we'll come back to it. Okay, so now looking at this question, we have to kind of pull some information from previous lives, I suppose, and kind of do a little bit of, well, digging. So here we need to figure out what these sides are. You could figure out one of them and then just multiply it by 10, right? Because you have 10 of them. Now it's dividing this, what is this called? Decagon into 10 triangles. What is the measure of this angle in here? Can we figure this out? So if we know that the measure of a full circle all the way around is 360 degrees, and we've divided it into 10 sections, what is each one of these sections going to be? So the interior angles are 360 degrees divided by 10. So what is each of these triangle kind of corners going to be? 36 degrees. Now we're going to look over here at this bottom triangle and notice that they've divided it up into a right angle triangle. So then what is this little sliver corner angle going to be here? 18. So that's going to be 36 degrees divided by 2, so that's going to be 18 degrees. So now the triangle that I'm going to try to use and deem important in my life at the moment is this one right here. I'm just going to take this part and I'm going to draw it over here. All right, so this is going to be 18 degrees, and let's call this BC because that's what it's called here, and call that corner A because that's this corner right here. Now, what other measurements can I get for this triangle here? Do I know what this length is? What is it? So this is 4 all the way across, right? So we're going to divide that by 2, and we're going to get 2 feet right here. All right. So now, what do I need to figure out from this triangle in order to finish the question? What am I solving for? I need BC. So we need to find line BC. And then once we do that, what are we going to do with BC? Times it by 2. And then times that by 10. Perfect. Okay, so easy enough to figure out line BC? Yeah? So this is what? Opposite? This is hypotenuse. So what trig ratio am I going to use? Sine. So we've got SINE, whoa, 18 degrees equals opposite, which is line BC, over hypotenuse, which is 2 feet. Okay, so now I've got 2 and then times sine 18 degrees equals line BC. What is that? What could it be? Okay. All right, make sure, okay. All right, so we get 0.618, that's for just this little. And then what do we do with that? Okay, so then we're going to multiply that by 2. So I want 2 times line BC, and that's going to equal 2 times 0.618, blah, 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 keep my decimals. That's, and then on here I'm just going to go times 2, and then I get 1.2. Okay, so that is for line, what is this called? I can also call this line BD, right? So BD is equal to 1.2 and so on. Okay, don't round. I'm not rounding. Now what do I do with this number? Times this by 10. So 10 times line BD is equal to, I could just go times 10, and I get 12.36. Okay? All right, times 10. So that equals 12.36, blah, blah, blah. And what does the question say round? Question says round to the nearest foot. So the length of the window, or the length of the wood material, is approximately 12 feet. And there you have it. So there's your homework questions, and I gotta show you this because I had so much fun doing this. You might think I'm a dork, but you see it? Do you get it? And then you've got your triangle there as well. Okay, so there you have it. There's your homework, and we'll see you next time.